Alrighty, good afternoon, good morning, good evening. My name is Blake Davis, and I'm a tutor with MathWorld Academy. I teach math and physics. And today we're going to be doing a short little demo session, maybe 10, 15 minutes or so. We're going to be going through this AP Calculus AB FRQ problem. So we have three parts here, and we're going to go ahead and get on with it. We're going to start by reading the question. So, a remote-controlled toy car moves back and forth along a straight path so that its velocity at time t is given by the function v, where v of t is measured in feet per second and t is measured in seconds. Then we have our piecewise function, which is of three parts. We're going to need to remember that for later. First, we have a polynomial of the fourth degree. Then we have a constant here, just a zero line. And lastly, we have a sinusoid. So we have three separate parts, and we're going to have to remember which ones are there, and we're going to have to pick carefully when it comes to the other parts of this problem. So, then we can take a look at the graph here. It gives us a nice little picture that'll help us with part B. But for now, let's move on and we'll go to part A. So we are to find the acceleration of the car at time t equals 1 second. We've got to show our work. So, what are we given? It's our first question. What are we given? Well, what we're given is velocity as a function of time, right? And if we know the definition of acceleration, we can see pretty easily that acceleration as a function of time is the derivative of velocity as a function of time. So, we know how to find our acceleration, but now we need to know which piece of our piecewise function to pick. We have three pieces here. So we know that we're supposed to find the acceleration at t equals 1 second. So what we can do is we can say, oh, well, I see right here that this is 0 to 4, and 1 falls in there. So we're going to use that first section, the fourth degree polynomial, when working to find our acceleration. So what we will have to do is take the derivative of our fourth degree polynomial. Which is just applying the power rule 3 times. So we can see that we will get 4t cubed minus 8 times 3 t squared plus 2 times 16 t. We can then simplify that a little bit. 8 times 3 is 24, and 2 times 16 is 32. Now we can plug in 1 for each of the t's, which 1 to any power is conveniently 1. So that means that we will be left with only our constants. Then we can add these up. So 4 minus 24 is negative 20, plus 32 is 12. So our answer is 12 feet per second squared. All right, so that's part A. Found our acceleration. But now we have to ask a question about our acceleration. Part B is not a math question, but a reasoning question. So it asks us, is the car speeding up or slowing down at time t equals 1 second? We've got to give a good reason for our answer. So let's think about this. At t equals 1 second. Well, first, one thing that we can do is we can look at the graph, right? We can see, okay, well, the graph is right here. And here, if we draw our tangent line, which is representative of our derivative, we can see pretty clearly that our velocity is increasing. So that's one way to tell that you're speeding up, is that our visual representation shows us such. Second, you can think about this in a more mathy kind of way. You could say, well, if I'm speeding up, that means that if I'm at, let's say, 2 meters per second, at time step 1, I'll add some number, say plus 5, and I'll end at 7 meters per second at another time step. If I'm slowing down, it would be the opposite, right? It would be 7 meters per second at time step 1, and 2 meters per second at time step 2. That would be -5 in our acceleration. So therefore, since our acceleration is positive, that tells us that the car is speeding up. Two different ways to find that one. Now our last part here is part C, which tells us to find the distance in feet that the car traveled over the time interval 0 is less than equal to t is less than equal to 4 seconds. We need to show the work that leads to our answer. Well, we're given velocity, not distance, so we need to take a different step. Similarly, though, to what we did in part A, where we note that acceleration is the derivative of velocity, we can work backwards. We can actually know that distance is the derivative of velocity. Or we can actually note that velocity is the derivative of distance. Therefore, using our fundamental theorem of calculus, we can integrate both of these sides, and we know that distance is the integral of velocity. So now, we take an integral. We go from 0 to 4 seconds as our bounds of our 4th degree polynomial here, which is t to the 4th minus 8t cubed plus 16t squared dt. Similarly to before, we can just distribute the integral, essentially. We'll have 3 separate integral power rules. So we will see that it is t to the 5th over 5 minus 8 over 4 t to the 4th plus 16 over 3 t to the 3rd. Evaluated from 0 to 4. Now, we can plug in our numbers. We can see where we end up. So what it will be is 4 to the 5th over 5 minus 8 over 4 is 2 times 4 to the 4th plus 16 over 3 times 4 to the 3rd. Now we are permitted a calculator on this section. So if you plug this into your calculator, or whatever is permitted at the time of taking this exam, you will see that it is 34.133 feet. That is the total distance covered between time step 0 and time step 4. So, I hope this was helpful. I hope this was an introduction to my style of teaching, how I like to go over at least problems in higher level high school mathematics, which is primarily what I teach. If you have any questions, of course, feel free to reach out to me or Pramod or whatever contact information you're given. We'll be glad to answer any questions that you might have. Thank you again. I hope you enjoyed this demo session, and I hope to be working with you soon. Bye-bye.